What's the problem transferring risk? You do that every single day. We get on the road, we drive around, we do transfers of risk all the time. The question is, are you being ethical in your transfers of risk? So I come in at this from a very different perspective than a lot of people. I know there's going to be some other veterans in here. I'm a combat veteran, also former law enforcement, federal law enforcement. And I've investigated over 200 injuries in basically high voltage industry over the past 2 decades. This is the way that I take a look at the continuum of a risk and basically harm, because that's what we're looking at. Serious injuries and fatalities, SIFs, just talked about. Start down on the lower bottom. You got your forced transfer of harm. I am going to hurt you. I am an expert in that. I'm a United States Marine. I've been taught how to use weapons to destroy things and to destroy people. I'm also a United States Coast Guard officer, so hey, I'm also on this side right here. I will jump into the water to save you. I have actually made myself a human shield. That's the kind of stuff that we do. Occupationally, we also have this, the forced transfer of risk, where we're going to force ourselves to transfer risk to somebody else because we don't want to handle it, we don't want to deal with it. We also have the ignorant transfer of risk. For most people, ding, 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 myself, I do this all the time. I'm ignorant of what I do because I'm relying on industry standards, I'm relying on specifications, I'm relying on prior engineering and everything else like that. Hey, it worked in the past, it's good enough. Send it. Larry the Cable Guy. Get her done. Then we got the known and unfunded transfer risk. Basically, I'm going to exploit you. Hey, I know I'm giving you the risk. Go, you deal with it. Then you have the unknown acceptance of the risk. Those are the people that he was just talking about. Hey, I'm brand new. I'm 22 years old. I don't have any life experience. I've got 2 days of training and orientation coming onto this job site. I have no idea what's going on, but boy, do I need this job. Then you got the known and funded transfer risk. Everybody does this too. How many people have a car insurance contract with the company? Everybody. There's a risk. I pay for it, and that's what I do. Okay? Then I got the known acceptance of risk. Hey, I'm going on the road. I'm going to get in my car. My car has all these safety features on it. I've got other people that are on the road. I accept that risk. And then I got the known absorption of harm. I am going to be the hero. I'm going to be the human shield. I would argue that for an occupational exposure, data center, I don't care, whatever else, forcing somebody to be the hero because you did this or this is unethical, the wrong way to go. This guy right here, I don't know if you can see it down at the bottom, electric, blasting cap. You got your igniter, you got your fuse, you got your blasting cap up there. You should actually have it over top of his helmet because that will blow up his face. So when you crimp those things on, a little explosive that actually generates an entire chain. You do it up here. So that if it blows up, you're just going to lose 2 hands. You're not going to die from it. Avoiding the SIF because you're sacrificing some other part. Symmetry and asymmetry. How many people here, as an engineer, as a designer, as a safety professional, have been injured by the system that they put into place? I would argue nobody. But how many people downstream of the decisions that we have made have had to investigate injuries on the basis of what we have done in transfer risk or have failed to do? It's asymmetrical. Go way, way back into history, one of the first known laws set up, which is a code of Hammurabi. If you go into the Louvre Museum in France, you can actually see the pillar of it. It's written in various languages, and it was posted for everybody to see. what was the major thing that the Code of Hammurabi did? It made the risk symmetrical. Under the Code of Hammurabi, if you built a house and it collapsed and killed the owner, you got killed. If it collapsed and killed the owner and his family, you and your family were killed. The Romans actually had this where if you built a bridge, your family had to live underneath of it for a period of time, a week, month, whatever it was. The Bible has a golden rule. Do unto others as you would have them do unto you. Limit. Don't do unto others what you would not have them do unto you. So I want you to invert that. Basically, what I want you to do is I want you to think about all the risks that you have that you are ready to transfer and say, if I was going to be the most destructive person, if I was going to be the United States Marine that was going to set up an ambush for the enemy, how would I do that the best? How would I ensure that people would die? How would I ensure people would be maimed? And then correct with that. Flip it in your head. So risk starts out, hey, we're going to build a data center, whatever it is. And as you go on, you end up with that risk accumulates to the people that are going to be exposed to it until finally, boom, absorption event. An absorption event basically means that you are dead, maimed, or disabled. That's your SIP. There's other parts of this too. By the project stage and the decisions that you make, and this is just a typical one, it can be everything. Some stages there's almost no risk transfer, other stages it's going to be incredible. But every single time, the person that is constructing it, maintaining it, repairing it, or switching it is going to be exposed. You need to arrange to have that and to lower that risk at every single stage that you're making these decisions. Be ethical in terms of how you transfer that risk. George Washington. Now I know this is a little politically incorrect because we're dealing with some British here. He was considered to be a great leader. Why was he considered to be such a great leader? And I would answer that he has skin in the game. When he got onto that battlefield and he got in front of those troops and he was leading them, they said it was like adding a whole nother division to the troops because it was such a morale boost. In the past, the leaders were actually subjected to the same risk as the troops that they were leading. They were out front. How many of the Roman emperors actually died in their sleep? Almost none. Because they were out on the battlefield. They had skin in the game. They were leading it. They knew exactly what the risks were. Previous speaker basically talked about this already. There's a new book up by Matt Hollowell. I encourage you to get it. It's expensive. It's like $60, $100, whatever, on Amazon right now. One of the absolute best things that you can do. Take a look at these energy sources and basically say, oh, hey, there it is right there. Outstanding work. I mean, this is something I've been following for years. He's put out a whole bunch of papers. If you follow this and you basically take a look at what could happen. Now, everybody's familiar with the standard risk table, okay? And you got probability and consequence. Skip out the probability, it doesn't work. It doesn't matter. And the reason why is under the law of big numbers, you can't ever calculate it properly, and you always have the risk. So the only thing you can do is absorb that risk. You also have to, part of design and planning and everything that we do, have to look at human factors. So what are the human factors that we're talking about? Primary motivational factors. Am I thirsty? Am I hungry? Is my temperature regulated? All those things. Secondary. Purpose, autonomy, mastery. Those are the things that people are looking at being able to do. resources? Do I have the time? Do I have the stuff to be able to do it? Or am I in the Larry the Cable Guy situation where I got to get it done and I got nothing to work with? There were planes that were dropping out of the sky in the Marine Corps because in their depot they had a restriction on a particular wrench that was used to tighten stuff down, so guys were making do. They had 2 wrenches for the entire depot. They had to be signed out. Nobody would turn it back in because everybody needed them. How did they solve the problem? They issued everybody a wrench and had a spare for them. Number of incidents of planes dropping out of the sky. It was a command decision to provide the resources. Competency. There's going to be other speakers talking about that. We're doing a lot of work on that. What is the person's mood for the day? How do I, as an EHS professional, how do I, as an engineer, as a designer, influence somebody's mood? It's real easy. Give them something that's not frustrating to work at. Give them something that doesn't challenge and just assault their senses the entire time they're there. And of course, external factors, which is something that is going to be going on. There's data centers that are right next to a cornfield that every single time they harvest the corn, all that dust goes in there and just trashes every single filter that's in there. You got to plan for that kind of stuff. So, don't demoralize your people with a design that sucks away the humanity out of it. Don't put in a landmine. Something that you know is a booby trap. This isn't going to happen. Man, this is a 1 in a trillion shot. This is a 6 Sigma event. Guess what? Given enough time and enough variation, that is a guarantee to happen, and it is going to happen. The only way you can do it is to go back and minimize the amount of current that's going to be going to that person, if it's electrical or whatever that is. And don't set something up so they can fight shortcuts because they can't come up with another way to do it. So here's the drive checklist. There's all kinds of stuff that's on here that is not part of your typical design criteria. But these are the kinds of things that you need to go through to think through, how is this going to transfer risk? How am I going to be able to be ethical in this and to be able to inform the other people? Lots of questions to ask. Invert it, flip it, understand you're going to have to go through some of this stuff as a thought experiment. But then, hey, the people that you're going to be operating your equipment, this is your tribe. This is your family. I want you to think about your designs, the kind of policies and procedures and work instructions you put in place that is suitable for your 13-year-old kid if they were forced to work there with sketchy management, poor leadership, ignorance, and they're immature. Because I guarantee you get somebody that is down on sleep, really hungry, really tired, just had a fight with their spouse, and their dog just died. That's the kind of person that's going to be in there. If they're going to show up to work, are they going to be at their best? No, we have to design around that. Another thing, lockout, tagout. There's a company here that has a good software system for that, but also local control. Can I see that visual open? Or is it hidden behind something? Do we have to trust something for that? The greater the current, the more they need the visual open. And then here's another one, small transformers. They can be used to limit the energy as well. Just had an incident where a guy ended up getting an arc flash. He was not wearing his gear. He was doing everything wrong. But because there was a small transformer there, rather than getting the entire run to the grid, the transformer failed and saved his life. He ended up with some third-degree burns over only about 10% of his body. Saved his life. Here's where the skin of the game comes. If you are a senior person in this program, in this process, participate in commissioning, go in on the first maintenance cycle, go in on the hands-on for repairs. The more you do this, the better you're going to be. And here's the big reason why. The feedback loop when it comes to engineering standards, regulations, and specifications is long. And if anybody wants to have a really good example of this, put it into Slido and say, Carl, tell the long feedback story. It's really cool. Don't have enough time, we've got other speakers. But embodied knowledge where you actually learn it is so much more. We talk about AI. AI is great. Here's the problem with AI. It can only deal with the information that exists. You will only ever get about 0.3%, and that's just a SWAG, on paper where AI can discover it. The rest of it is going to be in your head. And the only way that you're going to be able to get that is you're shoulder to shoulder with another person actually working with them. What he did right there with getting the older people in there, went all the way around AI and made that person to person and created the tribe where people cared. Why did the people respond to the aunts and uncles? Because there was an affinity there. They cared. Huge, huge improvement. Every design transfers risk. We need to minimize the energy and the consequences of it. Everything that you think, this can never happen, is going to happen. It is going to take somebody's life with sufficient energy because you're going to have enough iterations to be able to make that work. All human life is fragile. Four of us at 5 o'clock in the morning, Dan was down there with me, pumping iron, immediately putting stress on our bodies, trying to make ourselves anti-fragile, to grow, to be able to exceed what we are if we were just a slug sitting on the couch. But there's a limit. Don't test that limit in your designs, in your processes, procedures, and anything else like that. Don't force people to be there. And if you're a really senior person here and you have the ability to get your engineers out into the field and have them participate, have them have that skin in the game so that their feedback loop shortens right up, and they get that embodied knowledge, and you're going to end up with much better designs, much faster, much more reliable gear with much, much lower injuries. So, skin in the game, be knowledgeable of how you transfer risk. Make sure that's ethical when you're transferring that risk. Make certain that you write it down, and that goes directly to the next person in the line. Everybody knows. Let's do this well and do it ethically. Thank you very much.